We all know that crossover designs is one of the most important factors that determines the sound quality of speakers. And in this series of videos, we're going to challenge the famous engineer Andrew Jones' design, the Pioneer Elite SP-EBS73 bookshelf speakers, by fine-tuning the crossover to reach its full potential. Now we can take off the back plate to reveal the crossover as well as the connection to the speaker. So we'll take a look what we can do to further improve the performance. The stock performance is very good. However, when you look at the measurement, later on I will show you the measurement. It's not far from ideal. So removing 4 screws, 1, 2, 3, 4. Then the port. The port is a little tight here, so you need some tool here to remove it. Okay. It's a little bit tight. So what I did, I used my finger inside the port to rock it out. Because this is a single piece, you can see it's a plastic piece. You can slowly pull it out. Of course, you can disconnect these things. Before I do that, I want to make sure I know the connection way. So the bottom 2 pins are for negative and the top 2 for positive. I believe one is for woofer, the other is for the mid-range. And the top 2, similar thing, but it is for the Atmos speaker. So if you look inside, you can see the crossover there. I believe the top one is probably for the Atmos, and bottom there should be one too. So let me remove it. The construction is pretty good. There's a flare inside as well to prevent port noise. So quite smart. And after removing the connections, we have, so this one you can see is to the mid-range. This one to the woofer from inside. And this one must be to the Atmos. We probably will need to remove the drivers from front in order to touch the crossover. I can see it here, and 2 panels up there. Of course, one panel for the tweeter, and the other is for the Atmos, and I think those two should be the same. So for the tweeter, we can see, pretty nice. Okay. We need to move the woofer from front. We first remove the rear. The rear is a single piece. You can see 1, 2, 3, 4 screws, you can pry it out with the port together and disconnect the cable. And then you need to remove the front woofer. So you first remove this plastic piece, pry it out, and then 4 screws hold the woofer. And this is the woofer. It's quite good quality. Large magnet, aluminum cone with a nice spider and I think it's 1.5 inch voice coil. So it should be very good at low frequency. So you can take a look inside. This is a crossover. Let me bring up some light here. So the crossover, you can see this is the main inductor. Very thin copper, meaning significant amount of resistance. That's why when we look at the curve, our low frequency is kind of about a couple dB lower than the mid-range. So we're going to take a closer look at the crossover and measure the inductance and see what we can do. We removed the crossover out. Again, it's designed by Andrew Jones. It turns out quite complicated for this. Again, it's 3-way crossover. This part is only for the woofer. So it's a low pass filter. And I measured the inductor and then recovered the diagram of this crossover. It first come over a 5 millihenry inductor, and to ground is a 180 microfarad capacitor. So this is a second order. This is third order. With the measurement may not be right, but this is smaller inductor. I measured 2.5. I think it's close to 3. About a 3 millihenry inductor. And then there is a notch filter here. Basically, it's a 7 millihenry inductor in series with a 130 microfarad capacitor and a 4.7 ohm resistor. So this is a notch filter. So let's take a look. The problem actually, it's pretty nice. Third order with a notch filter. Very nice design. And expensive. You see the components. But there's a problem here. Basically, you can see these inductors, because they're very high inductance, and they use kind of thin wires. You have to use thin wires to get these high inductance. So the resistance is significant. On the 5 millihenry, we're talking about 0.6 ohm resistance in series, and because of the copper wire. And on the 3 millihenry inductor, we're talking about 0.4 ohm in series resistance. So if you add these together, it's about 1 ohm. This is the problem. 1 ohm resistance, and you take a look here. This is a 4 ohm woofer. In series 1 ohm resistance, we're talking about significant insertion loss, or in other words, attenuation. I think about 2 dB or so attenuation. So the difference between this and the mid-range, the 2 dB difference actually comes from this crossover. So what we can do, a few things we can do. I think, first of all, do we really need a third order here, and also the notch filter? I will do some simulation and see if I remove this, make it a simple second order, because then the phase and everything will be much better, and also the resistance will be reduced to 0.6 ohm, so our attenuation will be much lower. Next step is go take a look on the mid-range and the tweeter crossover. So the cover is kind of difficult to remove on the mid-range and tweeter. So you don't have to remove it. You can directly remove the crossover inside the box once you have the rear port removed. There are 4 screws hold this crossover board, and by removing those 4 screws you should be able to take out this crossover board just like this. So one is for tweeter connection, one is for mid-range. I think I don't need to disconnect, otherwise you have to remember the way they are connected. So I just take it out and take a look at the crossover, and then I can work right on the board here and put it back. That way we don't have to remember the connection inside. Otherwise there's a phase issue. We'll take a look at the phase. So this is from the rear post, input post. So I believe the yellow is for tweeter, and yellow is for mid-range probably, and the white is for tweeter. But we can take a look at the crossover, we can figure it out. And there's another crossover inside, should be the same as this one. That one is for the Atmos speaker on top. We take out the high frequency and mid-range crossover board, and then we trace down the circuit and measure the values, and here is the result. Basically, from the input to the mid-range, we have a 68 microfarad in series, and then a 0.33 ohm resistor, and then in series a 0.5 millihenry, and then to the negative pole of the mid-range. So because this is the second order for the mid-range, 0.5 millihenry for the high frequency cutoff. This one is for the low frequency cutoff. So this one with this capacitor, we have a second order filter here, and this is in series with a 0.1 millihenry. This is a notch filter kind of. again, it cuts off faster at a high frequency. And then in parallel, a 7 millihenry. This is for the low frequency cutoff. Again, it's the second order. So we can see both high frequency and low frequency are second order for the mid-range. And however, in the in the woofer, we have a third order with a notch filter. It's more like a fourth order kind of crossover. That's why I want to keep the woofer part again second order. We'll think twice on that one. So this is relatively easy to understand. Now we have a slight issue was the mid-range is a little bit too much. So the measurement about 2 to 3 dB higher. One way is we lift the woofer output a little bit by reducing the series resistance we mentioned earlier. Another way is to increase this resistor so that we have attenuation for the mid-range. And for the tweeter, this is a third order crossover. So it first comes to a 2.2 microfarad and in series with a 3.3 ohm and shunt inductor 0.5 millihenry. So this is, basically mirror with this one. And then in series a 7.5 microfarad. So this one actually, the combination of this third order make the high frequency tail a little bit higher. So actually our measurements show that beyond 10,000 hertz, we have a little bit too much high frequency. So we probably will adjust the topology here to tune down the very high frequency part. Okay, so now we have a rough idea, and then we will do some simulation to make sure the exact numbers, and then we can do some modification. Again, this one, if you look at the crossover, is a non-polarized electric capacitor. So we'll probably change this one to a film capacitor. I have a 50 microfarad film capacitor, and if needed, I can parallel with a 10 microfarad. I have a 20, 28, and 10. So we'll think about this part because this is a very important capacitor. This kind of capacitor probably no good to the mid-range sound. And this inductor is this one. I believe it is a farad core. It could be easily saturated at very high power. So my thinking is even to remove this one, because this one is basically trying to shut off the low frequency content. We might think about some other ways, like put a resistor here. We need to think twice what we do here.